Hello, this is Jeffrey Fox here. We're doing Big Data Applications and Analytics, the course which is part of our data science curriculum. And now we're coming to the section on sports informatics, which could equally well be called sports analytics. Actually, that's probably what is more commonly referred to in the field. This section has 3 units. The first 2 units are dominantly on baseball, which is possibly the best developed of all sports for reasons we'll soon see. Basically, there's just more data on baseball, and the data is cleaner and more easily related to the success of a team. And the first lesson is what we're doing here, which is an introduction to the field and to baseball. The baseball study is called Sabermetrics by its definition, and in this particular unit we have 3 lessons, and they're basically an overview of the sort of basic sabermetrics, not terribly recent developments, although it's an up-to-date discussion, but its methods have been known for some time. So we just remind ourselves what we're doing. We're doing big data, and our ecosystem is using clouds, running data analytics collaboratively, processing the big data to solve problems in X informatics, where X is sports or baseball in this particular discussion. Here are the values of X defined for informatics. I did not see sports as defined in this area, but it is often you will see sports analytics used. So maybe I should put it down and list fields where you use analytics or informatics. And of course, our education initiative is data science. Here are the standard collage of all the various informatics fields we found on the web. And we don't need to go through that again. There are just an amazing number of them. All right, so this is a summary of the section. And it points out that analytics is use in sports is growing rapidly. And that's partly due to more and more statistics, and partly due to the realization that those statistics can be used in a deeper fashion than they had in the past. And we will also go through more sophisticated measures, which are typically based on video or sensor records of what the players or if it's say horse racing, the horses are doing in the sports. And I say we are starting with baseball, and if you look at baseball, it has an interesting feature that is actually dominated by individuals or individuals in pairs, and it's unlike say basketball, where you might have a lot of people, or soccer, where you might have a lot of people involved in a particular play. Here, the play is rather focused and isolated, which means that you can sort of record the result of a given action, whether it's a pitch or a hit or a fielding action, in a very precise fashion and associate that with a particular player. We will discuss these video technologies, which PitchFX and FieldFX are possibly the best known, and those video measures are getting to much larger volumes of data than the previous raw statistics of the results of pitches and the results of hits. We will also look at the interplay between the actual economics of the sports for baseball and the analytics. And later on, after baseball, we'll look at the wearables and lots of other sports, including soccer, the Olympics, American football, NFL, basketball, NBA, tennis, and horse racing. So let's get going, and we're going on to this first lesson on an introduction to sabermetrics. And this actually here describes the unit. The unit has 3 lessons, as we described. And this, I've already essentially pointed out that this unit discusses basic sabermetrics. And there's a famous movie that I recommend you look at called Moneyball, which describes how sabermetrics was used by the Oakland Athletics over 10 years ago to greatly improve their performance. And we look at, in this unit, not only the classic baseball averages, but sophisticated measures, and that's in the last lesson, which are called wins above replacement, a rather subtle concept, though still based on relatively straightforward data. And here's our first lesson, finally. We do a very short introduction to all sports analytics / informatics. We will discuss the economic model of baseball, the value of a win, and the performance dollar relationship. So here is a very broad sort of summary of essentially one of the things that's driving sports analytics. And this is not actually quite so true for baseball, because baseball has always used analytics and is not driven so much as some of the other applications by Moore's law, because it's Moore's law that is giving us lots of sensors and the ability to put memory and processing power and efficient batteries on those sensors. So, and also those sensors are now getting so small that you can cover people with them. Although that's an interesting development, that's more important in things like the wearables used for consumer sports or consumer recreation. Baseball does, as I mentioned, use a lot of video, and the fact that video is now much cheaper and higher performance and is, of course, a feature of Moore's law. All right, so we know that sports analytics is very important, at least if you read the literature, you will see it is. Whether every team really understands that well and exploits it, I don't think that's quite true yet. But I think the better performing teams know this well. I remember a time when in 1990, lots of people went to Wall Street to do analytics. They were called quants. Often they were like me, a physicist. I was a physicist at that time. And now, if you like, the quants are moving into the management offices of sports teams. And of course, sports is very big business with teams value measured in billions of dollars. And as we've already pointed out, sports analytics is applicable to all fields, essentially. I don't know anyone that it's not applicable to, but it is much more prominent and, if you like, successful, or maybe it's just better developed in baseball. As we'll mention, there are important to realize the different data sources. So one is, which is the basis of most this early discussion of baseball, is statistics on actions within the game. Well, in that every game has statistics. It is Fred shot the ball at the net from 15 feet away, and it so at the basketball net, and they went in or out. So that's an action which is recorded. In the case of baseball, a pitcher pitches a ball of a certain style at a certain speed. It falls in or out of the strike zone in a certain position and is hit by the hitter in some fashion that's its final location and the action, a foul ball, a caught ball, a home run, a single, or what have you, is recorded. Then we have another obvious source of data. If you just record almost any activity with video, you can analyze that real-time video. That's getting a lot easier simply because, again, due to increased computer power and also just lots of work in the computer vision community, you're able to identify from video, the player and the ball and things like that. You can, although in general it's very hard to do image processing, as long as you know your video is a video of a baseball game, is probably I don't think it's terribly stressful or challenging to actually do a very detailed analysis. Another approach, which is very common, horse racing uses it. you can say consumer sports wearables use this, is you just have sensors. Those sensors are either locating the position of a person or a horse, or they're locating the heart rate or things like that. And that heart rate is an example of custom instruments, as in the large fitness um, and wearables initiative, which is growing rapidly in importance. If you look on the internet, you will not find, I did not find any very good modern books on sports analytics. There are several conferences, some by this SABR, Society for American Baseball Research, which obviously has a baseball focus. They have a good conference, I think it's each year. And MIT has an amazingly broad, successful conference. Their sports analytics conference, again, I think it's nowadays each year. Another thing that is stressed is there are many people involved in sports. They're players, they're fans, they're the management, there's the media. Media are involved simply because of advertising. A lot of the revenue for sports, and the revenue is what governs decisions, because sports is a business, that comes from advertising, and that advertising is related to the performance of the teams and so on. You have sports equipment manufacturers, and you have just sort of pride. I mean, a given country is very keen that its representatives do well at the Olympics and things like that. And of course, there's not only country pride, there are team pride. The New York Yankees are notorious for having a very, very vehemently supportive fan base. So here again, we're going through these types of data, which are really three-way data: the precise numerical data on the results of activities, the sensors that are tracked, and video. I would say this type of data is reasonably well described and is the origin of most sports analytics at the moment. Sensors are quite useful for the media broadcasting the results of sports or tracking the sports, but they're not so clearly. I didn't find many examples of where they were translated into strong decisions on how to sort of make sports decisions, which batter to play, or I don't know if you're doing football, how to arrange a team and things like that to create the most success. There's clear use of video, and partly just to make video to generate numerical data, because the video can tell you, for instance, in say baseball, it will tell you the speed of the ball, how fast it was thrown, whether it was a curveball or a changeup or a knuckleball and what have you. And it will also tell you where it arrived in the pitching zone, and then that position in the pitching zone can be tracked for a given batter, and to see if that batter is more successful depending on where the ball arrives and things like that. So video, which is huge data because it's just streams and streams of frames, it tends to get processed by video, which is really image processing, to get a few rather precise numbers. So if you want to know how all this analytics is used, it's used to predict results, to make decisions on the how to play the game. You know, which players to put on the team, which type of strategy to use, a defensive strategy, an aggressive strategy, or what have you. And also in like games like baseball, where you can change and you can actually change the players during the game, like bring in so-called relief pitchers. And in the case of the NFL, when you're allowed to, of course, the quarterback or the coach / quarterback choose the play to do at each down. Those decisions can be highly influenced by this data. Of course, everything is a probability, because these are people and the people don't always perform in the same way. You try to characterize their performance probabilistically, and then you, of course, cannot guarantee anything, but you choose the play or hire the player it seems most likely to succeed. Now, there's a final class of information which is correlated with the video, namely, which is just to visualize what's going on. Now, that visualization is, if you like, what you do of image data when you don't have a clear algorithm to process that image data into results. So you can use a spatial visualization of, say, a tennis game where the balls are dropping and things like that, or where the field goal throws are successful, or where the passes and runs are successful in the NFL. So spatial visualization is very important because games are played in the real world, a three-dimensional world. So you get Google Maps type analyses, which effectively layer on the playing field, or whatever it be for whichever game it is, some visualization of what happened in the past, and that is you could sort of, that's what you do when you're trying to work out how to use data. You use spatial visualization. All right, so that was the end of the overview of the entire field. Now we come on to sabermetrics, which is you can see it's defined in Wikipedia. Wikipedia, of course, has almost everything in the world. You can replace Wikipedia, me by Wikipedia pretty easily if you want. And by definition, sabermetrics is the empirical or analytics associated with baseball. And it measures in-game activity and produces results which actually lead to different decisions which change the in-game activity. And it comes from the Society for American Baseball Research, which is SABR, although sabermetrics has an E in it. This fellow, Bill James, is a hero in the baseball area, as a pioneer in this field, and is an advocate of the technology used. If you look at sabermetrics, the first sort of round of sabermetrics, which is what, say, the Oakland A's used, that is built around actually new measures of success, like wins above replacement to measure the performance of a player, or value over replacement player to measure a slightly different way of saying the same thing. And they're trying to find out quantitative measures of the overall success of players, and in particular, the success of players in a particular scenario with a particular pitcher or a particular style of pitcher, say left-handed or right-handed, and which is the player that's most likely to succeed in that spot. And as we'll see, it is pretty sensitive to lots of other interesting issues, because wins at certain times of the season, wins are more or less important, because if you're nearing the end of the season and your team is in contention for a playoff spot, wins are hugely important. They're actually worth more in money than they were at the beginning of the season. And if you're a team which is out of contention, you're too far behind the leaders, then it's probably not worth spending a lot of money on a player who will increase your wins. It's better to probably spend that money more strategically. So there's lots of interesting interplays between measures of success and the dollar value that it comes out of that success. And I say, we will find that some of these sabermetric measures are aimed at quantifying the runs produced, because it's runs that win ball games. Well, we've mentioned Moneyball. Here is Brad Pitt, the star of Moneyball. It's 2011 was the film. The book was in 2003, where the has this charming title, The Art of Winning an Unfair Game. And it corresponds to the story of the Oakland Athletics in 2002, who won the American League West with a very impressive record of 103 to 59. You always play 162 games in the baseball season. And this innovative general manager used Sabermetrics. He also, one aspect of the sort of success in baseball is how you get good players. You either use a farm system, which is your minor league teams where you groom new players, and or you just buy players from other teams. And of course, if you buy players from other teams, your salary tends to go up. And here for 2002 was the team salary for as a function of teams. So you can see here the Oakland A's at somewhat around $40 million total team salary. That's the sum of raw players. Is quite a lot less than the New York Yankees, which are up over 120 million. So there's a factor of, I believe, 2.8 between them. So in order, because, and the range of these team salaries is not really a reflection of the generosity or otherwise of the owners. It's not because baseball's not run as a charity and for the public good. It is run as a business, and in New York, you're going to get more fans and higher income, especially when you fold in the income from the cable media outlets which are attached to your team. You just get more money in New York, and that money translates into more salaries for the players. And as you and also, which we'll see, New York is particularly sensitive to how well it does. If it does well, it gets a lot of interest from the huge population of New York. If it doesn't do well, it gets less interest, and its revenue significantly declines. So there's a huge premium in New York for winning games and getting into the playoffs and being very competitive. So these issues are very nicely described in a relatively actually old book now called Diamond Dollars by Vince Gennaro. Vince is Columbia and is clearly a pioneer in this field and possibly the leading practitioner at the moment. He has both a good book, good lectures on the web, and also a good blog, which I used extensively in these lectures. And Diamond Dollars is not really a discussion of sabermetrics per se. It's really a discussion of the baseball as a business and how the economic model for baseball interacts with the analytics. Because the value of a player is not an absolute number. A player could have a different value for the different teams because those different teams are subject to different economics. Vince does the example of the Atlanta Braves, where it appears the fans are rather laid back and don't really respond terribly badly to not doing so well, or don't actually respond very dramatically to doing well. So there's not a strong correlation between revenue and success, whereas the Yankees have a high correlation between revenue and success. So the Yankees can afford, in fact, ought to spend more money at critical times to try to ensure that team gets through into the playoffs. And those issues are described in great detail in this book. And so that's described a little more on this page here. Here is the previous one was the team. We had a picture which actually had the high number to the right here. The high numbers to the left is still the New York Yankees. This is the revenue in 2013, and we have the Yankees up here at 471, and the poor old well, actually, here we have the Oakland A's still back here down at 173, and the bottom three are all 167, 169, 173 million. Of course, these are not trivial numbers, but they're not 471. And this points out that there is significant differences in revenue per team. And the next one here, of course, is another very competitive team in a big market, the Boston Red Sox. And here's Philadelphia Phillies, Oakland, Chicago Cubs, San Francisco. This is the first West Coast team. And it's roughly the same as a little more than the Los Angeles Dodgers, which are here at 245. But still, the Dodgers is almost half only a little more than half the Yankees. So there's a big difference, even though Los Angeles is actually comparable in size to New York, and actually New York has two teams, Mets and Yankees, and Los Angeles has two teams, Angels and Dodgers. But somehow there are these big differences. It's worth noting this is a pretty successful game. Baseball here is the attendance. Even in this world of everything being electronic, the actual attendance at the game, at the ballpark, is still increasing as a function of time. There are these various dips here, possibly due to strikes and other things, but it's effectively increasing relatively strongly with year. We go from 1960 at less than 200, and we're now almost at 800 in 2014. And this is a measure. I mean, this is an important input that I mentioned. The sports media, yes, is the Yankees cable media outlet. It also has um, basketball and football, and you can see the revenue of this media outlet, which doesn't all go to the Yankees. They just have a portion of that revenue. It's almost well, in 2012 it was over $500 million. Pretty good money. And you can see here other ones, Fox Sports Southwest, Madison Square, another New York one, Fox Sports West, ... Here's actually New England, which I assume is the Boston Red Sox. That is quite a lot lower than the New York stations. And now, here's something I've already mentioned, which is discussed in this book, that when you're fighting for a playoff, wins are more important than if you're not competitive. So the dollars you'll spend to get the 90th win, which is more likely to make you into the playoffs. I remember the 162 games, so 80th win is not so exciting. It's only half the wins in half the games. So a 90th win is worth more than the 80th because it's directly related to the playoffs. And so here you can say wins are worth around $5 million on the margin. That means when those wins really count. So another thing discussed in this book is the value of new stadia and how that translates into baseball economics. So here if we look at a player and try to ask how much you should pay that player in salary. So, I mean, you might, in a naive, idealistic world, you'll just want to look at the performance on the field. And that's what Sabermetrics will directly give you. The wins above replacement are a measure of the performance on the field and how many wins that you might get extra from this particular player. But the player's actual value depends on where the team is situated. If the team is doing lousily, a great player is actually not so valuable because it's probably going to make little difference in the results. Another obvious point is other teams. I mean, if there's another team just about to really needing, let's say it's a right fielder, really wanting a right fielder, and then the value of right fielders in other teams goes up because there's somebody who it's a seller's market and somebody wants to buy that person. And of course, it matters how many people the club has at that position, whether the nature of the contract, whether the player is near the end of their contract or not and about to go into so-called free agency. And the final thing is just pizzazz. Certain players, well, like in basketball, Michael Jordan, have pizzazz. And that pizzazz, which is here called marquee value, obviously translates into salary. And there are also teams have made brands. The Yankees are the most obvious. They won the World Championship 26 times in 85 years. That's pretty impressive. And Cubs and Red Sox, which are all in big metropolises, have important clear team brands. And the final thing that's pointed out in Diamond Dollars is that the win is roughly equivalent to 10 runs. That's how you translate runs into wins. So we're going to stop here. The next lesson will go through some various sabermetric measures. Thank you very much. This is the end of the first lesson of the first unit in the Sports Informatics or Sports Analytics section. This is Jeffrey Fox signing off. Thank you.